I wanted to do some examples for project number 3, which is going to involve what's called the standard normal curve. We've talked about straight line graphs, but this is a curved graph, and it looks like this. It's a well-known shape. And here's -1, 0's in the middle, and 1 is about there. Technically speaking, this would be called the cumulative distribution function for a standard normal random variable x. I'll leave the math major discussions out of this. For what I want to talk about here is that the probabilities that this random variable x is contained in a certain interval can be represented by area under this graph, and that's what I want you to do for this project, is just draw some pictures where shaded areas that represent probabilities on this graph are done. So I'm going to just jump into an example. So for an example, shade in the area that represents the probability, and I'm using this capital letter P standing for probability. Say that 0 is less than x, x is the standard normal random variable, is less than 1. So this variable x is between 0 and 1, and that area in the standard normal curve, if I draw a picture of the curve, here's -1, 0, 1. So if I draw a vertical line at 0, which is right on the y-axis, and a vertical line at 1 that goes up to the top of the graph, it's this area that I'm shaded in that represents the probability that this random variable is between 0 and 1. Actually calculating that probability is a problem that I'm going to leave for a statistics class. But for right now, I just want you to be able to shade in the area on this graph that represents that probability. Here's another example. So shade in, say the probability, say -0.2 less than x less than 1.6. Now, I'm not going to get out a micrometer and start measuring here, but you should draw a reasonable representation of the graph. 0 is in the middle, 1 is about there, -1 is about there. Now, -0.2 is a little bit in the negative side, pretty close to 0 there. Let's say that's -0.2. 1.6, I'm going to say, is about over there. So I'm going to draw a vertical line at -0.2, a vertical line at 1.6, and shade in the area between those two vertical lines. Now sometimes they'll ask a question like this. Here's another example. Find the probability, say that x is greater than -0.5. So it doesn't say it's in between two numbers, but it's just greater than -0.5. In this situation, here's 0, here's -1, here's 1. X is greater than -0.5, so I'm going to put in -0.5 is about there, and it starts there, and because x is greater than, it's all the area to the right of -0.5. So in theory, this graph goes on forever and ever and ever, kind of like this. So it's all the area starting from -0.5 to the right is the probability that x is greater than -0.5. Here's another example. Say if I said find the probability that x is less than -1. Well, this is a similar situation. Here's the picture. Here's the standard normal curve. 0 is there. Say there's 1, there's -1. Now because x is less than -1, it's all the area to the left of -1. So if I put a vertical line there, it's this shaded area, and in theory the graph goes on forever and ever towards the left.